So always try to remove these dots, because these dots creates a lot of problems. Sometimes they're shorted the thing. So now let us,
It's okay.
yeah, there should be a dot. You cannot remove this dot. If you would like to remove it, the whole thing will be. If there is a node or junction, then there will be a dot. Here there is no dot. Here there is no dot. You understand me? Okay. So now here, no dot. And let us put it little bit up. So this is an AC source. You can select this AC source as well as you can select the function generator. You remember the function generator? They are same. So using AC source, you can find this AC source from here. If you click here, this is AC voltage source, AC current source. Okay. So now
change the values.
Yes, how to change these values? This is a black one, right?
Yes.
And the black one 5 volt. Peak value is 5 volt. RMS they are giving us. What is the frequency? 10 kilohertz. You can change to kilohertz to hertz or kilohertz. You understand me?
Our RMS, we
Yeah.
put it like this. We
You
don't
do
change.
no. If you change the amplitude, the RMS will change by automatically. Okay. So it's root 2. They know it. Okay.
Okay.
So they will change it by themselves. So this is the circuit. And they brought all the blue elements. But I was saying you guys to bring the black elements. So this is the black one. Because in the black one you can change it 1.5 to whatever. You understand me? But the blue ones they are fixed. So it's better to use the black ones. Is it clear? So now this is our circuit. What is missing? The ground. I think the ground was there. Anyway, so let us draw the ground. So this is the circuit. So this is our circuit. Why it is nanofarad?
22.
Okay, so let us remove it. Remove this one as well. And bring it from the black one. Because it will confuse you in the exam, right? If you come here, it will not confuse you anymore. How much they want?
0.02 micro.
Yeah, 0.002 micro. 0.002.
No.
Oh, 022. 022 microfarad. You can change micro to nano, nano to farad, whatever you want. So now it is not confusing you. So you put the exact values, right?
Yeah.
So otherwise nano, pico, what is this? So I'm in exam, so I cannot think anymore. So you will see the problems. And if your numbers are not correct, you will lose points, right? Okay, so and for others you can bring the black elements.
Why here he in the picture he put a junction?
Come here, he put to
Junction,
let you
and you
understand that you need to measure from these 2 points. Okay?
Yes.
So this is our circuit. So where is our oscilloscope? Oscilloscope, I guess this one. This is what? Function generator. Oscilloscope. So this is the oscilloscope. And from this oscilloscope, you know, this is our channel 1. This is our channel 1. This is our ground. This ground and the circuit ground should be same. And this is our channel B. And they are saying put the channel B here. This is for table number 2.
Yes.
This is for the table number 2. And we know we can change its color here. But in oscilloscope, you cannot do anything.
You told us to bring this one down.
Not now. I didn't tell you anything like this, so you did not understand it, okay? Do not blame me. So I told you to follow the procedures. First procedures, they are asking you to build the figure 1. This is not figure 1, okay? When you do the measurement, when you come to step number 5, you will change the circuit. You understand me? Clear? Okay. And always follow the steps given in your manual or in your exam sheets. Okay? Because many students can ask many questions to the instructors. Maybe instructors is not in the right position. He is asking something, he is understanding anything else. So, and you cannot blame him. Okay? I'm not saying that it's only for me, for anyone. So now this is our circuit, right? So let us run it. We run it. And also the frequency is 10 kilohertz, as they are saying 10 kilohertz. We run it, so let us see what is the circuit. So it seems that signal is going and it's not measurable. Okay, so what we need to do, we need to change something here. 5, okay, so it means we are getting a good signals, right? So, and also from here we can change something. So we can change something here as well. Okay.
It depends on the what
Yeah.
number you choose.
Yeah, you can choose any numbers, okay? So it will not change anything in this oscilloscope. Oscilloscope will just measure
Okay.
with the big figures or small figure. If you put the plus sign or the 0 in a small size or big size, it doesn't matter. This is 0, right? Or plus is plus. So now this is our system. We put AC for all of them. So let us stop the signal. So we stop the signal and let us make it little bit bigger. So this is a nice one, right? So here, if you would like to measure what is your values, so you have the cursor here, right? You put the cursor at the maximum value. Okay, so this is VV1. The one is 4.9, but it was supposed to be 5, right? We applied 5 volts. So this is another cursor. So it's not 5 exactly, but you can little bit change it. You will get 5. Okay, maybe this one. Okay, this is 5. This is at the top. Okay. And for the other one, other signal, this is not the top. BV2. They are showing us 509, but this is not the maximum for this one. How to get the maximum value? You can come here. So this is the maximum. You can play a little bit and you will see which one is the maximum. So it's increasing. Now it's increasing, and decreasing. So we found
3.6.
yeah 3.6. Not this one. The VV1. One is this is for A1. This is for B1. Okay. You understand it? And you can bring yeah.
Why you use this one?
You can bring it here, right? Okay. We found this is the. If you play it little bit here, you'll find the minimum value. Minimum we found 674, right? And maximum will also be 674. There is no way. Because minimum maximum we applied the same voltage.
You are measuring the value of V at maximum?
Yes, maximum. Okay, at maximum. So now this is our values. So what is the peak to peak values? They give us directly 1.3. V peak to peak. So for this one, this is 1.3. You understand me?
Yes.
So here we are measuring IC across this one. So this current is IC current.
Why you put the volt here, the volt A here?
Yes, you can put it here. In that case, you have to divide it the total impedance. So we put it here. This voltage divided by this resistor, it will give us this current, right?
Yes, but still put it here.
No, this is A, and this is B, and we are dealing with the blue one, right?
The A is the A.
Yeah, yeah.
The one, the original.
Yeah, A is the original. VA
Okay.
and VV. So it's related to V. Is it clear?
Yes.
Okay. So now we can write this is 1.3. So it's because of you can change it here, you can change it there, but this is the magnitude. Magnitude is 1.3. So we write it 1.3 over 2. Or you can directly take these values 674 millivolt. You can write directly 0.674. So this is the voltage and phase shift. So now we need to measure the phase shift. To measure the phase shift, let us make the signals little bit bigger. So now signal is much more bigger. So if you bring this one here, this is the zero crossing, right? And this is also the zero crossing for other signal. You understand me?
What's the yes.
So it's
Ah,
crossing the zero line.
Yes, yes.
It's crossing the zero line.
Yes.
Is it clear?
Yeah.
So now tau. What is t? 12.5 second. Microsecond. 12.5 microsecond. Okay? How much is this? They found tau equal to 12.5 microsecond. Okay, they put it in degree. This in some manuals I found they are in radian. Maybe here. Okay, make it degree. Okay.
Why 12.5?
Why 12.5 from here?
From here you get it.
T2 minus T1, the time. Time is the x-axis.
T2 here 7.
T2 is this one, and T1 is this one. This is 2.
The difference between them.
This is 2, and this is 1. You understand it? The
But
difference
here
between
T2 is 7 milli.
yes.
And when you minus it 0.
Yes, 0, but millisecond. So this in micro, they are even. So this is not exactly 7. So maybe 6.9 nanometers.
Okay.
So you will take it here, from here. From here you cannot take it, 0. But it's not 0, right? So this is 12 point, to take these values, 12.5 microsecond, you have it. So now you can find theta equal to 360 multiplied with tau over t. What is t?
Need to find T.
T is already, you can find t from this here. T equal to 1 over f. You know the frequency 1 over 10k, 10 into 10 to the 3. So you can find it in microseconds. Is it clear?
Yes.
So in the same way,
Or multiply by frequency. Yeah, we can multiply the
yeah, you can multiply with frequency, no problem.
directly.
It's okay. So now, this is your circuit. Next time you just follow the steps given here. Is it clear to all the software groups?
Yes.
Okay, so now go back to your table, do the measurements, and I would like to see that all of you have your manual in front of you. And you are reading everything from the manual.
Doctor, there is no
Okay?
steps for
If I do not find the manual with you, then I'll consider you as an absent. Okay? Because we want to give you the manual to bring it, right? And the